All right, excellent. So look at this for me. Right, so we're going to do one example. Write this for me. 20 AB raised to the third power divided by 5A raised to the second power times B. Let me show you how it should look mathematically. There we go. Bam. Everyone have this? 20A raised to the B raised to the third power divided by 5A raised to the second power times B. Everyone have that?
Yes, sir.
Right, good. Now, we're going to essentially go through a procedure to solve this. So let's write the procedure. The procedure to solve this question goes a little like this. Step 1. Let's go. Step 1. The first step is to cancel. Let me put it here. There we go. The first step is to cancel common factors. There we go. Now, let's look closely into this fraction first. Is there anything that is common to both fractions, 20 and 5? Do we have anything in common between those two numbers? Let me draw it for you. So look at this drawing for me. We have 20 on one side. We have 20 on one side. Right? Times A. My bad. Times A. B raised to the 3. All divided by 5. A raised to the squared B. Right. I want one intelligent person to tell me, is there anything in common with the 20 and the 5? In other words, can you simplify that 20 and the 5?
Yes, sir. Yes, sir.
So what could we say? 5 into 5 goes 1 time, right?
1.
And then 5 into 20 goes how many times?
4.
4. Right. 4. 4.
So I thought you were talking about 200.
Oh, no.
Excuse me, sir. Can you go up, sir?
All right, let me go up. Is that better? There you go.
Yes, sir.
So in other words, right, the common factor that we canceled, we can simply say the common factor that we canceled was 5. Right? We canceled it to make the entire thing now be, let's write this, 4. Let's put this, 4A B raised to the third, B raised to the third, right, divided by A squared B. A squared B.
I think I got this step 2, sir.
We're going to go into step 2 because we've essentially simplified this. But step 2 now essentially says this. For common bases, comma, subtract the smaller index from the larger index. What was the index again? Anyone remembers? Right, exponent, same thing, Jazil, right? So in other words, tell me one exponent that you see in this question. We see 4, right? What power is A raised to?
3.
1, correct, because we're looking at A. That was a trick question, and Khalil picked it up. What power is A raised to? We say 1. So what power is B raised to?
B.
3.
B cubed, sir.
Right. What power is the A now in the other fraction raised to?
Sir, A squared.
Squared. And the last one, what power is the B in the second fraction raised to?
B1.
B1. So in other words now, we're going to do something with those bases. So we're going to say all of the powers we're going to have subtracting from the larger. So we're going to say we had a A2, so we're going to subtract 1 from the numerator. So we're going to say A2 minus 1. Understand?
Just A1.
Right, but follow along with me. Is that A1 going to go into the numerator or the denominator? Where did you subtract that 1 from?
The denominator, so you have to go into the numerator, sir, because A2 is too big to go into.
No, that's not correct. And here's why. Because we had 1 here. When we subtract 1 from this one, we get 0, correct?
Yes, sir.
Right. So that would give us essentially nothing here. But when we subtract 1 from this 2, what are we left with?
Nothing.
1A.
Nothing at all.
No, we're left with A to the 1. Correct. We're left with A to the 1.
We're left with 8.
A to the 1. The reason why is because when we had A to the 1 here and we subtracted 1, we got A to the 0, correct?
Yes, sir.
Right. That A to the 0 is essentially nothing. But when you subtracted 1 now from the A squared, what are you left with?
A to the 1.
That means that there's an A still remaining in the denominator. So we could rewrite this to say, let me rewrite this and show you. We could rewrite this to say that we have 4, right? A, 1 minus 1, 1 minus 1, right? B, let's do the B part now. The rule says we need to subtract the smaller index from the larger. So we would say B to the 3 minus this 1. Everybody with me?
Sir, I said that's the B squared when they do that, sir.
Right, correct. Let's look at this denominator now, right? What would we have left in the denominator now, guys? We would have... Repeat?
Sir, A to 1, sir.
All right, so I heard 2 answers, and let's pick apart those 2 answers. I heard firstly 0, right? We would have a 1 remaining from the 5 right here. So we put back the 1. We would have, well, 1A, because we said A, 2 minus 1 gives us A to the 1. So we don't only have 1A right here, correct? But let's look at the B now. If we had B to the 1 and we subtracted 1, are we left with any B's?
No, sir.
No. So that means we only have really 1A or just A in the denominator. So we can rewrite this to say we therefore have, let me show you. Therefore have, the answer therefore will be 4 B squared, right? Divided by just A. All right, excellent. Okay, now there's a last thing I want to put as the final step. Even though you have this answer, always look if you can simplify further. Always look if the fraction can be simplified further. So let me ask the question. Can this fraction be simplified any further? In other words, do we have anything in common in the numerator and the denominator? No.
No, sir.
We don't have a 4 in the denominator or any multiples of 4, and we don't have any B's in the denominator. So therefore, this answer is correct because we cannot simplify it. Everybody with me? So that's the procedure. Let's do one more example. All right, now we're gonna do a simpler one. Let me just show you real quick. How about if we had 3? My bad. How about if we had 3x squared 3x squared, right? My bad. 3x squared minus, right? 9x, all divided by, right? X to the third. All right? There we go. What's step one again? Step one?
Cancel the common factors.
Cancel common factors. But there's going to be an interesting question, Jazil. Right? You never cancel common factors that are, well, we can actually. So we can actually say there's a relationship between 3 and 9, correct?
Yes, sir.
Right. How many 3's do we need to get to 9?
3.
Right. So in other words, we can pull out that 3 that we need to get to 9 and factor what we have there. So we could say, look at this for me. We need 3 3's to get to 9. So we can factorize that expression, 3x squared minus 9x, due to the fact that 3 is common to both. So when we pull out that 3 now, there we go. Follow along with me. We're going to put what we have remaining, right? So when we take a 3 from 3x squared, what are we left with? When we take a 3 from 3x squared, if we pull out that 3, what are we left with?
X squared.
Excellent. X squared. Follow along with me. When we pull out now another 3, and let's do it step by step just to ensure you understand. Let me just put this there. 1 second. There we go. So when we pull out another 3 now out of this 9x, how many 3's do you say we needed again to get to 9?
3, sir.
We needed 3. So when we pull out 3 times 3, we can essentially say, well, we have 3. But is that the only thing we have left? Because 3 times 3 gives us 9. But what else did we have on that 9?
X.
Excellent. X. Follow along with me. So that was canceling the common factors. Because look at this for me now. When we multiply 3 times x squared, what do we get? 3x squared, right?
Yes, sir.
And when we multiply 3 times negative 3x, what do we get? This right here, negative 9x. So we get back essentially what we had. So let's write this out. This step is called factorizing a bracket. We pull out terms that is common to both and factorize as such. And factorize. There we go. So in other words, let me repeat one last time. Because there was a 3 that is common to 3x squared minus 9x, we pulled it out. But I want to ask one final question before I stop talking. Do we have anything in common between x squared and x?
Sir, the X.
Excellent. So that means that, can we go a step further and pull out the x as well?
Yes, sir.
Excellent. So stick with me now. So we could pull out another x beside this 3 and say, well, hold on, we're not finished. We're going to pull out our x as well. So when we remove one x from x squared, what do we have left?
X.
Excellent. Excellent. So we have one x remaining there. And this class is being recorded, so not to worry. Right? When we pull out our x from negative 9x, what do we have remaining? Negative 9, just
9.
Right, so just 9 alone, because the x is gone. So we can essentially pull out this x here. Excellent. And let me explain something cool. You see, if we wanted to get back this answer, guys, this 3x squared minus 9x, all we would need to do is to expand this bracket. Does that make sense? Does that make sense? Because we essentially shortcut or factorize what we had. We pulled out everything that is common to each, right? And then just make them into a multiplication bracket. Because if we said 3x times x, what would that give us? 3x squared, right? And if you were to say as well, 3x times negative 3, right? First of all, let's remove the negative for now. What is 3 times 3? 9, right? And what is 9 times x? 9x. So that essentially, this is a shortcut or an easier way to express this expression. Does that make sense, everyone?
Yes, sir.
All right, let me give you a moment to write it off. One moment to write it off.
Sir,
and then,
sir, where is the 3x, the x cube? Where did that go, sir?
The x cube? Oh, we haven't touched that yet. Not to worry, we haven't touched that yet. We're only dealing with the numerator right now because we're taking it step by step and we're canceling the factors in the numerator. All right, so let me give you one moment to write it off, and then we're going to pick up and go. All right, one moment. Khalil seemed to have left the room. I just accepted him back.
What did you say, sir?
Yeah, did you leave the room by accident?
Sir, it got disconnected, sir. Sir, there's something on your screen, sir. Can you remove it, sir?
Not a problem. One sec. I'm just checking if anyone else got disconnected. All right. Okay. So you're the only person. Okay, good. So yeah, just write this off for me. Right. Not a problem. So Khalil. Not to worry, Khalil. The class was recorded. So what I want you to do after class, you're gonna go on the YouTube page and you're gonna watch what you missed. Okay. All right. So what we're gonna do now? One more. My bad. Let's go right there. Okay, good. So I'm gonna pause the recording here and I'm gonna call this part 1 of the class. You're gonna watch this part again after just to get